Good afternoon, sir.
Good afternoon, good afternoon. So, we'll start our discussion. Please tell me if ano sa inyong end ang presentation. Is it visible already? Okay, sige. Thank you. So, let's do the mirror equation. So, I want you to prepare again any notes, papers, pens, pencils, calculators, because we'll be dealing with more of the formulas from light. So let's have mirror equation. So there's a main question between the mirror and lenses. Are we going to use the same equation from the mirror and sa lenses? Actually, there will be cases that we will be using the same formula. Pero the the thing there is that when we will be interpreting the answer of the mirror and the lens, medyo light na rin siya. Yes, there will be what do you call this one? Another explanation behind the objective of the lens and of course the objective of the mirror. So the image form depends on this for the mirror equation. The image form depends on the size, location, and focal length of the object. You can still remember if we have this reflection of yours in the mirror. Let's try to see the mirror that we have is the plane mirror. No? Let's see that let's visualize the incident. And na mirror in front of you, a plane mirror. Whole body na siya. So, the image that will be formed inside that mirror is dependent on the, let's say, on the distance. Okay? First, the location. What is the size of that? What is the size of the object and what is the size of the subject? Some, uh, most cases, especially if especially the structure of the plane mirror is naka-rectangular siya in a vertical manner. So those who are very fat, for example, no offense, no, katong mga tambok, usually pag ang ilang pag plane mirror ay nangatubango tapos naka-vertical tapos medyo naka-narrow ang iyang sides. Ang kay tabo na nagkaniwang sila tan-awon, di ba? And sometimes po, katong mga niwang po, pag magtanaw sila sa mga mirror, plain mirror, for example, na medyo flat siya, naka-square ang iyang size, but naka-human size ang iyahang ang iyahang length. Usually, nagtambok sila tanaw. So, yan na, there are some cases. Now, this relationship, known as the mirror equation, that we can express via mathematical expression. So, we have 1 over f is equals to 1 over dO plus 1 over di, wherein the f here is the focal length. It means it's from the object and the subject. So the subject is outside the mirror and the object inside the mirror. The dO will be the distance of the object from the mirror, and the di is the distance of the image from the mirror. So this is what you meant by depending the equation on the distance. So the ratio of the size of the image, like SI, which means the size of the image, and the size of the object or SO is called the linear magnification. The magnification is related to the distances of the mirror. Remember the word magnify, diba? But if you talk about magnification, if you talk about magnifying, it means that you are resizing the shape or the size or the structure of the object. Like most objects that are so small, if you'll be using the what the law of magnification, those small objects now will turn into large object. And some magnifying glass as well or magnifying kind of object can can resize the object from large to small. Like, sir, can we relate that one to the lenses? Now, ang lenses magod na po siya another magnifying effect. And actually, like magnifying effect. It's not the same thing when it comes to the mirror equation or to the mirror. So, for us to understand the function of the linear magnification to the distance of to the mirror of the mirror, we have SI over SO is equals to negative VR over DO. Okay, this table here will explain to us the real thing about how linear magnification is really related to the distance of the mirror. Like for example, if the mirror is concave and it creates a real and virtual image, the object now will be positive. What is the positive image? And for the concave view, we have the positive object. We have a positive image and a positive focal length. It means that the size of the object is the same thing with the size of the image and with respect to the length. So if you're too near, then the image that will be formed is near. If you're too far, then the image that will be formed is far as well. For the virtual, we have here the object, which is positive. The image now here is negative and the focal length is positive. This time now, if our object here is, for example, we have an object that is placed in a 5-meter distance, and then the image that will be shown virtually from the mirror will be, let's say, there's a saying it's blurred. Okay, it's not totally copying the same image na nasa object, but the focal length here is positive as well. Why? The distance now, it's very kind of bit I call this one. It's very tricky because the focal length here between the object and the image are different. So most object that has a virtual image nga mo for means that it's not the length that has something to do with it. It's the result. But the real question is, sir, unsa ka klase na siya nga mirror ang ginagamit why makakreate siya ina na image? Like say for example that the concave mirror really can alter the image that has that the object has its original na structure. Diba? Like most cases sa mga stores before ang CCTV na-invent or na uso is they're more on the mirror because they can usually see the whole the whole area. Okay, but there is an alteration bit of the shape of that object. So that is the result of the image. For the context on the virtual, okay, on the convex mirror that is virtual, the object now is positive, which means there's no we have here the object ang victim, no? And the image is negative and the focal length is negative. Now the convex sa convex man good we have now the light that is countering part the objective of the image. So if the object now cannot be altered, so on the convex mirror, the image now will create a virtual it will not create a virtual picture. Okay? Why negative atong focal length nani? It's because the light now will not be totally 100% nga burukan siya to reflect directly to the mirror. Instead, there will be deflection that will happen that will create a virtual image. So, kung ikaw, ang imong shape sa imong lawas is gabi ka na dawa kag lawas. Pag abot na sa image nimo, medyo ma-reshape ka, no? Medyo maniwang ka. Okay, that is what is happening sa And sa focal length depending na din siya dayon. Because it doesn't mean that you are too near. It means that ang imong image nga ma-create also is near. No. Ang ma-create nimong image it's too far because again, we have a convex mirror involved. Okay, there will be a diffraction of light that will happen. Instead nga, mo directly siya, ma-enter siya rito sa mirror, mukuan siya, no? Mag-change the direction. How can we apply those equations in a sample problem? So we have here a sample problem. An object which is 5 centimeter high is placed in a 10 centimeter from a concave mirror whose focal length is 8 centimeter. Calculate the location and the size of the image. So what we're looking here sa atong first example is that, okay, let's state the given set. We have here a size of the object which is 5 centimeter. That is the height of the object. We also have here that the distance of the object, which is 10 centimeter. And then our focal length is 8 centimeter. Concave mirror man siya, so we will expect that the image here can either be positive and the other is negative. Let's try to see if there is really a change, no? So our task here is to calculate the location and the size of the image. So we're looking for the DI, or the distance of the image, and then the size of the image. First, let's look for the distance of the image. We'll be using the formula 1 over f is equals to 1 over DO plus 1 over DI. So since we're looking for the DI here, we need to assume that ganang kwan, let's try to do the kwan, the, what do you call this one? Transverse, no? Magkwanta, mag-assume ta nga, there is a kwan. May tabo dani nga ka na may ma-transfer. Okay? So, substituting the given values, no, we have our f, which is 8 centimeter. So 1 over 8 centimeter is equals to 1 over 10 centimeter plus our 1 over di. Now, since we're looking for the di, ato i-transpose niya. Okay? So, asa dani ang i-transpose nato? So, ang ma-transpose dani is si 10 centimeter, di ba? Si 1 over DO. So, pag transpose dito ni 1 over DO sa PCAS, may mo siyang 1 over DI is equals to 8 centimeter minus 1 over 10 centimeter. Okay. So, after this one, what will be the next thing that we will do? Di ba? So, sa mathematics, natay di ba, sa mathematics, atong i-kuan, natay, sabi term na niya, natay ka na, atong i-kuan, no? Natay i-times, naputoy i-minus, kaya mo man na siya na dani. So, just like sa mathematics man good, we have first to kuan, we need to, try to, what do you call this one? Mangita taog ka ng LCD niya, diba? The least common denominator. Pag wala tayong kanang kuan LCD, let's look for the kuan GCF, diba? Great kanang kuan, greatest common factor nila. So, dani nga equation, wala tay laing kuan, wala tay lain kanang common nga answer sa atong denominator, atong less common denominator, or atong GCF. So, let's say nga, let's use kanang 80 here. Okay? So, sa 80 is from 8 times 10. Now, sa 80, ato na siyang equal sa 80, dani sa duha. Okay? Ano sa duha man. So, mura bitaw sa kuan bitaw, kana bitaw, imo bitaw na siya. Okay. 10 times 1 is 10, 8 times 1 is 8. Okay, and then iyada yung kuan na iyada yung atong pag-o din nga denominator is 80. So we have now 8 centimeter minus 8 centimeter divided by 80 centimeter squared. So after this one, we will be now ato na siya i-minus, no? We have 10 minus 8, so we have 2 centimeter, and then ato siya i-divide sa 80. So we have an answer of 40 centimeter. Actually, it's not 40 centimeter. It's 1 over 40. Okay? So 1 over 40, kung atong i-equal siya ang 1 over 40, we'll have an answer of 40 centimeters. So nabutang siya nga, 1 over 2 centimeter divided by 80 centimeters squared is equals to 40 centimeters. So kung namoy ka na calculator diya, scientific, you can actually get the real answer here. So we have 2 divided by 80. So our DI here is 40 centimeter. Our next one is we'll be looking for the size. Okay, what will be the size DI sa ato ang sa ato ang object or sa itong image. I'm sorry, sa image na to. So we'll be using the formula SI over SO is equals to negative DI over DO. So more ta on the linear magnification nga case here. So to get the SI, we'll be uh, creating a new formula, no? From derived ta. So we have SI now is equals to SO times negative DI divided by DO. So we'll be cross multiplying everything here, and then canceling the SI will give us this new equation. After that one, we need now to substitute the given values. So we have 5 centimeter. So 5 centimeter uh, times negative 40 centimeter divided by 10 centimeter. Okay. Take note ano na 40 na negative siya, Danny, because our equation here, our formula here is negative DI siya. So kung siya, no? Whatever mga values na mabutang Danny sa DI, positive or negative, it will turn into, depending on the integers that will be used. So if negative atong 40 Danny, tapos negative ang DI, positive mo dyan na siya to. I-multiply na itong duwa. But since atong 40 Danny is positive man, and our equation here is naka-negative. So we have negative 40 centimeter divided by 10 centimeter. Multiply the two, 5 times negative 40, then you'll have negative 200 centimeters squared divided by 10, then you'll have the answer of negative 20 centimeter. The negative sign here will indicate that the image is inverted. Pasabot na concave mirror siya, and our image here is, let's try to find out. Okay, we have a vertical image that was formed, okay, in a concave mirror. Any questions so far before we proceed to the next one? Wala. So nasabta na ang nasabta na iyahang uh, calculation involved. Okay. Okay, I will leave this one as your assignment. Let's move on to the next. I still have one. We will end up at 2:15 plus akin. Nasa to'y ating nga research. Okay, so let's talk about index of refraction. Okay, index of refraction is somewhat like it's somewhat like opposite sa ato ang reflection. But the formula that we'll be using here is n is equal to the speed of the light in a vacuum, which is represented by small letter c, divided by the speed of light in another materials, which is represented by v. The speed of light in a vacuum that we're talking about here, class, is actually the the constant value of the speed of light. Diba? It's 3.0 times 10 to the power of 8. And then the speed of light in another materials will now be calculated as our index of refraction. So, not all the time, we will be using not all the time, the speed of light can actually be, pwede siya, no, what do you call this one? Mura tag race bitaw class nga. Plus, mura tag, kung ikaw ang champion, ikaw si speed of light, has a constant value of 3.0 times 10 to the power of 8, dari ka kakompetensya pag kalain. But the kakompetensya ni mga lain has a different source. So we need to find out the index of refraction. Why is that another speed of light is depending on the materials that was used. Like for example, this one. Calculate the index of refraction of a crown glass. Take note we are using the crown glass. Okay, if the speed of the light in the glass is at 2.0 times 10 to the power of 8. Let's try to visualize that the crown glass that we're talking about here can actually absorb a light, but can absorb and refract the light, creating its own speed, no? Like kanang kwan. Atong ikuan ko no ang kanang dubot sa baso. Kanang lubot sa baso ato ang example as our crown glass. Now, Ang lupot sa baso na kuno, was na light mo reflect na it can only be, it can only have, or it can only convert another speed of light that has a value of 2.0 times 10 to the power of 8, a meter per second. So let's try to see daw kuno how much, how much index of that ground glass really caused the speed of the light on the glass to refract with only 2.0 times 10 to the power of 8 meter per second speed na result. Di ba? So, i-reflect ang light, ang natural light, dito sa lubot sa baso, and then nag-refract ang baso, nag-create another light, okay? Which is 2.0 times 10 to the power of 8 na lang. So, let's try to find out the index. So, we have a given, which is the glass, that has a 2.0 times 10 to the power of 8 a meter per second speed. And then also our speed of the vacuum. So, we have 3.0 times 10 to the power of 8 a meter per second. To find our answer here, just substitute the given values using the formula n is equals to c divided by v. So we have 3.0 times 10 to the power of 8 meter per second divided by 2.0 times 10 to the power of 8 meter per second. And then after dividing the two, you'll get the answer of 1.5. Okay. There is no unit for the index of refraction because we're trying to look for ikwan lang, no? How much light was being refracted dito. Pila di ang nabilin sulod sa count glass. Why niya, or usa di kabaga ang count glass. Ngano niya to na yung reflect na light. So the random values for the indexes of the refraction for the light has actually its own, has a wavelength. Okay? I did not put here anymore the kwan glass, the different indexes sa different materials because it's kung naman pwede na ito ma-search na But remember, it doesn't mean that you will not all materials na provided sa internet really has an accurate number of indexes sa refraction. You can still calculate that one. If ever there are different speed of light involved in a certain materials together with our kind constant values of light, you can actually get another form of indexes depending on the materials na gigamit. Because, again, dili ng materials nipis, dili ng materials baga. Na ay different kind of glasses, di ba? Natin translucent, transparent, daghang kita klase. So, makadepende kaya po ng indexes na. Okay. Now, let's compare mirror to lenses. Any questions so far sa index of refraction? Or proceed to the lenses? Okay. How about the others? Si Philip ra, ang yung nawala.
Wala.
Wala. Actually, sa'yo naman kayo siya. Ang iyahang concept, wala lang dyan mo ka ng divide of multiply. Wala na confirm ito i-advise inyo. How about the lenses? Actually, the lenses, it has a same formula sa atong mirror. Okay, it uses magnifying, it uses the size of the image, the size of the object, even the distance also of the two. But this time, we have here another kind of equation. We call it power. It is the power that we're talking about here sa lenses is that sometimes there are times pang good that the effect of the lenses to the material is different. Diba? It can alter different sizes, structure, even colors when you use the lenses. Okay, sa glass, mga sa tao, mga sa eyeglass na grade 1 to 300 naman ganin na iyang glass. Okay. The more na siya magdaghan, the more magtaas tulo ang grade, the more siya strong ang iyang effect. Now, the equation for the lenses is we have 1 over f is equals to 1 over do plus 1 over di. So, it's the same thing sa atong mirror. Negative focal length means vertical image is formed. Okay? And then for the magnifying, we have si over so is equals to negative dr over do. Same thing. The magnification will always be depending on the size of the image and the object. And this is what I meant kanina about the use of the power. It has a unit of diopter, or d is equals to 1 over m. The m here is the focal length. So let's try to find out what is that. Okay, we have a sample situation here, okay, on how do we use the equation for the lenses. A small object that is 2 centimeter high is placed 10 centimeter from a double convex lens with a focal length of 12 centimeter. Describe the location and kind of image formed. Calculate the linear magnification of the lens. So we have a given of DO, which is 10 centimeter, F is 12 centimeter, and the SO is at 2 centimeter. Then find the DI, the SI, and the M. Okay, so if you can observe sa atong sample problem now, no? The difference dito sa ato ang mirror is that we're not looking for the magnification, because for the mirror man God, the linear magnification means the size of the image is equals to the distance of the image. At the same time, the size of the object is equals to the distance of the object. But here, man God, sa lenses, the magnification is real. Diba? It's very real because there's really a change that will happen because we're talking about lens here. And like I've said kanina, it has grades. Na siya level. Na siya level sa iyahang kabagao, na siya level sa iyang ma-form. So let's try to look for the DI here first. So 1 over F is equals to 1 over DO plus 1 over DI. So it's the same thing, no? Atong bottom, we will be replacing the different values dito sa atong substitute nato tanan. So we have 12 for F and 10 for our DO. So we have 1 over 12 centimeter is equals to 1 over 10 centimeter plus 1 DI. So transpose na punta, no? So we have 1 DI is equals to 1 over 12 centimeters plus, okay? Okay, I'm sorry, I forgot to write. It's negative plus, it's negative. I guess it's negative. Because we will be mag-transpose mo sa pikas. So, if it will be, kung mag-transpose og DI sa pikas, it will turn to negative. I suppose. Yeah. So, kung na to sa pikas, I'm sorry, pala na to ang 1 over 10 sa pikas, it will turn into negative. So, it's negative, I guess. So, we have 1 over 12 centimeter plus 1 over 10 centimeter is equals to 2 centimeter over 120 centimeter. Again, the 120 here that we're talking about is the greatest common factor nila. So we have 120. So we have 10 times 1 is 10, then 12 times 1 is 12. So, 10 minus 12, no, it's 12, at 10 minus 12 is negative 2 divided by 120 centimeter. And then since naka 1 over DI man ta, so we'll have 12 centimeter divided by 120 centimeter is negative 60 centimeter. Take note of the 60, the negative, the negative sign here came from the negative 2 centimeter that we have here. Okay? So, next, our B. Okay, so we have to look for the size of the image. The same thing that we did sa ato ang mirror, no? Substitute the given values because we need to derive a new formula coming from SI over SO is equals to negative DI over DO. So, by deriving a new formula, we have SI is equals to SO times negative DI divided by DO. So, substitute ta, 2 centimeter, tapos, times, okay? Remember what will happen gani pag ma-times ang ka negative, di ba ma-positive siya? So we have positive 60 centimeter divided by 10 centimeter. And then multiply the 2, then divide sa 10. So we have SI is equals to 120 centimeter squared divided by 10 centimeter. After dividing, we have now 12 centimeter as our size of the image. If we get the magnification of the size and the size of the image and the object, so we have 12 centimeter for the SI and 2 centimeter for the SO. Dividing the two, then you'll have an answer of 6. Okay, that is the magnification. So, times 6 siya. So, ikuan na. That's right upon nga there's i-zoom nimo ikaunom na ang kwan. Uh, ang size sa object o sa image. And that is the result. Okay? So, do you follow, class? Are you still there?
Yes, sir.
Yes,
Okay.
sir.
I'm sorry for my voice because the weather is kwan. The weather is fine. And the weather is so cold. Medyo kwan kayo. Baka makadani sa proseso. Okay. Let's move on to the kwan. To can you copy this one kasi kani sa sa kani kani nga to ang kanang supposed nga example, another example for the mirror. Can you copy this one and then try to answer? Okay, what would be the focal length of an object that is placed 25 centimeter from a concave mirror that is 45 centimeter high? And then how about the size of the object? Ang budget sa ilahang katuwang nakopy na? Everyone? Or na-screenshot na ba? Okay. So, how about this one? Can you copy this one? Na-screenshot na sa tanan? Okay. So, naman kayo dugang kwanta na discussion okay, before we end our class. So this will kwan. So how about the kwan, the power lens? So how about the power lens? Diba, since the power is equals to 1 over m, so 1 over m. Now, if we have a given, okay, if we have a given, makita na yun sa screen?
Yes, sir.
Okay, so okay. If we have a given of BO, which is 55 centimeter, and our DI, which is equal to, say, 45 centimeter, what will be the quantity? What will be So what will happen here? No? About getting the power lens. So, remember, di ba, if the power is equals to 1 over f, then we can assume that 1 over f is equals to 1 over 55. We will go back to the formula. 1 over dO, okay, that's 1 over di. It will be replacing the value of this one. So 1 over f is equals to, okay, 1 over 55 centimeter, that's addition to given values, plus 1 divided by 45 centimeter. Next, it's the same thing ang atong gamiton nga formula gyapon sa pagkuha sa mirror and sa lenses. So we'll be looking for the greatest common factor of the 55 and 45. So 55 times 45. So we have 2,000. So we have 2,475 as our common one, our greatest common factor. Okay, what will happen yan ni class? May mga siya, 45, okay? So kung magkwanta, so 45, because pag na ato sila i-cross multiply, ay, amo naman may tabo cross multiply man ta. So we have uh, si 45, si 45 centimeter is will be added by 55 centimeter, and then they will be divided by our 2475 centimeter na GCF. Next, i-add na to ang duha, no? So we have 100 centimeter now divided by 2475 centimeter. Pwede siya, class. So we have 2475 divided by 100. So we have 24.75 as our centimeter as our focal length. Di ba? Next, how do we get the power? Since power is equals to 1 over n. So ato na siya i-quan class, no? Ato na siya what do you call this one? Ato na siya i-divide sa 1. So pila man? 1 divided by 24.75 centimeter. Pila? 1 divided by 24.75 is 0.040 na lang ta. Okay, 0.040, yada yung unit of D. This is the diopter. Okay, this is the power lens. This is equal. This is since positive man ato ang kwan, no? Positive man ang ato ang focal length, it means that the image that was formed here is real image. Diba? So it's a real image. It means that the lens actually did not create any alteration to the image. Instead, what the lens did is i-copy lang niya ang structure sa ka-object and then reflected it to the size. So that's the connection between the point. So positive tanan from the focal length to the DI to the DO. Sir, will there be cases na pwede siya negative? Yes, because again, the negative sign will indicate if the image that was formed is either vertically inverted. So, naana siya yung mga cases ngayon na may tabo. Okay? Question so far? You can actually convert that one if you wanted to. Okay, let's convert this one. Let's convert it to into meter. Thank you so much for that, Philip. So if we have 0.40 centimeter, divide na siya sa kwan. Dito sa basic na lang ta. Let's try to kwan. Let's try to change this one to centimeter. If we have 24.75 divided by 100, because in every 1 meter there is 1 centimeter, if every 1 meter is 100 centimeter. So we have what, 1 over 0.2475. So what will be our answer now? Okay, it's 4.04 meter. Mura na po siya kwan, mura na po atong i-convert ang kwan, 0.040 into, yeah, mura itong times na nato, times 100. Oh, it's the same thing. No? 0.0404 times 100. You have 0.04 meter at the same time. Anyways, it's kwan man gyapon. Pero sakto si Philip ay, we have to convert the centimeter to meter because that's the kwan. That's the unit for the diopter. Thank you so much for that, Philip, for that clarification. Okay, any questions so far? None? Wala na? Okay. So, please try to answer those questions nga yung yung screenshot or copy. Pass that one tomorrow. Okay? Can you pass that one before 12 o'clock sa afternoon? Okay na ba? You can send that one sa kwan ng magbuhat ko ka ng room for that one. Para ito niya i-attach yan yung answer. Pictures or values. Okay? So that's it for this afternoon. Thank you so much for joining the class. Okay? May nagya po na nag-appeal sa inyo. Please do not share your answer to to your classmates. I'll be honest with you, polite. I'll be practical now. Okay? I will not give any consideration anymore. I don't care kung nakatake na mo sa inyong examinations, mga universities na ganan ninyo. Whatever reflection of the grades ninyo makuha, ikan sa kuha, that will be fine now. Okay? And it's not my fault anymore. If you will share your answer to your classmate without even considering the fact that they did not give their best, please, okay, do not blame yourselves. So that's it. Thank you so much, and you may now leave the class. Bye,
Thank you,
everyone.
sir. Thank you, sir.
Thank you, sir.
Yes, sir.